Hi, welcome back. In this video, we are going to look at partitioning, bucketing, and we'll look at how queries can be run on these partition and bucketed tables, how we can ingest data, how we can insert data into these different kinds of tables. Now, before we start, you might be knowing the reason that we partition a table. Uh, Quite a few of you might be well versed with Oracle or any RDBMS like SQL or place like that. So in those, what we do is we partition tables. The primary reason of partitioning a table is performance, to improve the performance of a query. In Hive 2, that is the one and only reason to partition a table. For those of you who had experience in partitioning tables in an RDBMS, it is very cumbersome. You got to write a function, then you got to decide which, whenever data comes in, which part the data goes to, which kind of partition the data goes. In Hive, this is somewhat simpler. Okay. So what we're going to see in this particular session is how to partition a table in Hive. Okay. First and foremost, we'll look at manual partition. Okay, what is manual partitioning? I'll explain it to you with the help of an example. Okay. So as we always do, we get into our Cloudera virtual machine. Hive is running. Okay. And we'll create a partitioned table, and this will be a manual partition. Now assume someone has given you files like these. Okay. Say I have a file called ukEdinburgh.csv. This is an employee file. Okay. So I got the employee number, name, salary and department. Okay. So these are all the employees resident in the UK and who are working in Edinburgh. So someone has given me a file. So this has been segregated. Okay. Then I have another file which has got similar data. It follows a similar format or a pattern. All of these employees who are resident in the UK but working in London. So employee number, name, salary and department. So it's exactly the same pattern. Now similarly, I've got employees from the USA who are working in California and employees in USA who are working in New York. So I got 4 different files. So someone has already segregated the data and given it to me. They have separated all the employees in the UK, all the employees in the USA, and they have again separated the employees based on the city that they work in. Okay. So this is the data that we have. Now once you have this data, your boss comes to you and says, okay, this is the data that I have. I want you to create a Hive table. So what's the first thing that comes to your mind? Okay, I'll create a table and I'll create a normal table, say employee table, and I'll keep on doing a append. Say every file, I'll say load data in path into this file into this particular table. Okay, so that is one way of doing it. But here, since we already know that data has been partitioned, okay, and they have been partitioned based on the country and the city, we can quickly think of a partition like this. Say we'll have a partition which will be, so we'll create a table which has got a partition like this. So we'll partition by, we'll create a table and we'll partition by because someone has country and city, because this will fit in with that pattern, data pattern that we have, and those 4 different files that we have. We have UK, USA, and here we have Edinburgh, London, and here you have New York and California. Okay, so it will be best to partition data this way, so country and city. Okay, so let's work on that example now. Okay, let's do some code. As like before, I already have created a script file. The script file will be provided to you. Okay, I'll explain you the syntax in a second. So creating a table is very similar to what we have been doing so far. Again, probably this is something new. It says if not exists, only then create. Okay, so I'm creating a managed table. As I mentioned before, there is no difference between a managed table and external table when it comes to all this partitioning and all the various operations that we do. Okay, so now we have a table. I am creating a table called employee underscore part, and here I am providing all the fields. So fields are 1, 2, 3, 4. So you get employee ID, name, salary, and department number. Okay, and probably you'll see a new line here, comment, which I have not used before, but just to complete the syntax, we'll use a new feature in every different table creation script. Okay, the most important bit is here, partitioned by country, city is string. Now if you look at this, these two things are not available in the data file. So there is no country, there is no city. All we know is the file belongs to a country and a city. Okay, and these two fields are not inside this data file. Okay, so this is how you create. So I say country string and city string, and then I create the table. So this table has been created. Now let's look at what's in the meta store. So what's in the on the warehouse. So I create in the warehouse, I have a EMPL part, that's the table that I created, and there's nothing inside here right now. Okay, but I do know that this table is a partition table, and this partition is based on country and city. Okay, good. So what next? Now we have to ingest the data, or we have to insert data into this file. Okay, it's a bit different than we do before. So you'll use the syntax load data local in path. Now as I said, these files are in the same folder that I have started Hive from. So I'll say load data in path UK underscore Edinburgh dot CSV into table. Okay, into table. What was the name of the table? EMPL underscore part partition. So that's the partition. Okay, and here I say country, I have to use the same name again. Country is equal to, in single quotes, I'll say UK comma city is equal to Edinburgh. I'll just use the initials ED. Okay, so that's about it. Now load data local in path, this file should get into this table, and the partitions I'm specifying. See, this file, this data should go into this partition. Now I can do anything here. I can just say India, and I can just say Mumbai, but obviously that is not right. Okay, so we are partitioning based on the data file that was given to us. So you got to be careful. If you make a mistake here, it is not Hive's responsibility, because you'll be querying based on these partitions. Okay, so load data local in path, into table EMPL, this one. Okay, so let me do an enter. So once I do that, the data is ingested. What do I do next? Let me load London now. So London will be similar, UK underscore London, right? And here in the end I'll say LON. Now be careful not to put overwrite here. When you key in overwrite, it will erase the contents of that table and insert a fresh one. Okay, so we want to append this data into that table. So let's do an enter again. Okay, now let's go back to the warehouse and see what's happened. Now that's the table that we have. Now if you, before we inserted the data, when we looked at this folder, it didn't have anything. Now if you click that, it will have two folders. Okay, so basically it had first partition is equal to country is equal to UK, second partitions would be Edinburgh and London. So these CSV files are dropped in that particular folder like we saw here. So the CSV files are dropped here and here. Okay, so let's do that again. Now let's go back and create another partition for country is equal to USA and city equal to California and New York. Okay, let's do that. Okay, so let's USA. Okay, California, and the other one would be New York. So let's go and have a look at the table again, or the warehouse directory. So you see a new partition, country is equal to USA, and you have California and New York. Okay, this is where the data has been stored. Now when you want to query this data, what would you want to query? You would want to query one partition of that particular table. Okay, so let's do a query now. So let's say select star from EMPL underscore part. Okay, so what happens when I do an EMPL underscore part? And well, let's do an order by e name. So when I do that, it is going to query the entire warehouse. Now there was no use of me creating a partition. I would want to force the user to query only one partition of that particular table. So to force users to use a predicate or a filter, what I would do is I'll set an environment variable saying force people to specify a partition when they are querying. So if I do that again, it will give me an error. Okay, sorry. I have to have some water. Anyway, so if I query this, now after I have set this environment variable, it gives me a prompt saying no partition predicate found. Okay, so I need to have a partition predicate. So what would I do? So I'll say show partitions empl underscore part. Okay. Now it has showed me all the partitions of this particular table. Now it becomes easier for me to query. So I'll say from ELP where country is equal to UK. Okay. So I got a filter in my predicate. So there you go. So it has just queried UK and not the entire data warehouse. Okay. So that's what it is. So a manual partition, in a manual partition, you create the table, you specify the partitions now based on what you think that data files are, or what you think those data files represent. Okay. What is the use case of this? Say for a manual partition, what kind of use cases you can have? Say example, you are having a lot of logs that are generated, one from Tomcat, say a server, another from a different source, say some kind of a log file from another source, and probably you are tailing one file. So all of this, the source we know one is coming from Tomcat and another one is another log from some other server, and here I am tailing a particular file which is generating some output, and I know all of them have a similar pattern. I have similar pattern like this. Okay. So this is the best possible way to partition data. So I'll create a table and I'll say partition by what? Source is equal to Tomcat. Oh, sorry, source, which could be a string, and then when I insert data, I'll say source is equal to Tomcat and source is equal to some log file. Okay. So when the data is already segregated, we know that this data is coming from a different source, and we know that we are 100% sure, then we can go for manual partitioning. But manual partitioning becomes somewhat cumbersome after some time. Now it is all well and fine when all the data is in production. You have created this table, say example, you have created this production table and you have ingested data. Once you have inserted data, everything is fine. But to insert data, it may take a very long time, because as you saw here, we were loading data one at a time, say one partition at a time. So this was one partition, this was another partition. Just imagine if you have 20 odd partitions, you'll have to do this 20 odd times. Yes, of course you can have an automated script that can do this for you, but one partition at a time, this is the downside of a manual partitioning. Okay. So how do we overcome this downside? Something Hive provides something else. Hive provides dynamic partitioning, okay, which solves the problem that we had with manual partitioning. Okay. So dynamic partitioning. Here we don't have to insert data one partition at a time. Okay. Right. But with dynamic partitioning, we'll have to follow certain steps. We will create a staging table where we'll have the data. Now we are creating the staging table just to show what dynamic partitioning is. Okay, but this staging table may already exist in your environment, in your system. Now this staging table, maybe it is running queries which are probably the queries that you run on this staging table is getting slower and slower. So somehow you need to make these queries faster. So what you do is you try and create another partitioned table. So we'll create a partition table. We create a partition table, we'll specify the partitions, and the third step what we'll do is we'll select data from 1 and insert into 2. So this is what we'll follow. But as I said, it could well be that this table is already existing in your system. Just to demonstrate dynamic partitioning, we'll be creating a staging table, and then we'll create a partition table, and we'll select data from the staging table and insert into our partition table. So these are the steps that we are going to follow. Okay, so let's jump into the code. As like before, I've created the tables, right? But here, okay, so copy, paste. So this is a staging table, okay, and the data that we are going to use has got all of this in there. Okay, this is another file that I'll just show it to you in a second. So that's the file that we are going to use. It's got data. So if you look at this, these fields and relate to these fields in there. So we have employee number, name, salary, department, country, city, and date of joining. Okay, so that's the meta information that I am giving you. Okay, so this is a file that I generated using a tool, using a small program, and to demonstrate a dynamic table. So here it's a staging table, and we are assuming that this staging table is present in our system. Okay, and let's insert data. Load data local in path emp into table empl stage. Okay, so say select star from empl underscore stage. Now we have this data around 400 odd records in there, 300 odd records in there. Okay, so assume now we can come back to that part. We are going to assume that this table is already existing, and the queries that are running on this table are very slow. Okay, so what do we do now? We'll create another a partition table. Okay, so let's do a partition table. Okay, I'll explain the syntax in a bit. So I'm saying create table, if not exists, production table, the same number, not the same number, but these are the columns in there. Now the difference between the previous table, the previous staging table, and this one would be department number. See, department number will be missing from this list. Okay, but department number will appear in this line, partitioned by department number. So I am taking off one of the fields, one of the columns, and saying, okay, partition by that column. Okay, so department number. So I am partitioning by the department number. Now you can partition by country or city, or say a year of joining. So you can partition by anything that you want to. Okay, but in this case I am going to partition by department number because I just have 5 departments. Okay, I'll explain it to you in a bit why you cannot partition by country and city or some other month or something like that, okay, or year of joining, right? So let's look at the syntax. Create table, employee production. All what it has is department number that is missing, and it has come into this partition. So missing department number appears in the partition column, okay, and I say enter. Now I've created a partitioned table. So let's look into this Hive warehouse and say EMPL stage, okay, and it has got the entire data. There is no partitioning there. And EMPL production, there is nothing in there because I have not inserted data, right? So EMPL production has got nothing under its folder structure. So what do I do next? The next thing that I do is I select data from staging table and insert into production table based on the partition, okay. So the query is a little bit specialized, okay, for that. Now first and foremost, before we do that, we have to set two properties. By default, dynamic partitioning is disabled, so we set this property to be true, saying set Hive dynamic partitioning to be true, okay. And we say there is another property that we set, dynamic partitioning mode is non-strict. Now if it is strict, it won't allow you to do a dynamic partitioning, okay. So let's do this first and I'll explain it to you later, okay. Now the third step would be this one. This one is the third step here. Select from one and insert into this, right? So let's do that. I have to explain you this query. It's a bit specialized. So I'll say insert overwrite into production table, EMPL production, the partition table, and the partition is specified by department number. Now the select should be like this. Select EMP number, salary and all of that, okay, and these columns should match the columns in EMPL production, but the partition column should be the last column to be appearing in the select statement, okay. So this one should be here, sorry, this department number should be the last one in the select statement, okay, from employee stage. So that is how the partition happens. So I do an enter in there. So what it will do is it will look at all the data that's in there, group by department number, and create the partition on department number, okay. Okay, so it has said loading partition this line. Now let's have a look at the folder, employee production. There you go, department number 1 and all employees of department number 1 are loaded. So map reduce job was run behind the scenes. In the reduce phase, the grouping was done based on the department and all data based on the department was segregated and the partition was created, okay. So let's do some tests. Let's do a count of star on staging table and see how much time it takes, which is a non-partition table. Employee stage is a non-partition table, correct? Right. It took 27.43 seconds, okay. So let's do the same query on production, the partition table. It is 26 seconds. Even though it is just 1 second less, this becomes a major performance gain when you have data in the which are in the order of 1 terabyte or 2 terabytes or 5 terabytes. Okay, so shaving off a second each on say 1 KB or a 20 KB of file, just imagine the amount of performance gains that you will get by partitioning a table. Okay, right. Now what I want you to observe is this employee production was partitioned based on department number. So 1, 2, 3, 4, 5. Let's have a look at the data again. Okay. So had we partitioned the data on country and city, what would have happened? So let's do this. Okay. So we partitioned the data. We did a dynamic partition. So that was dynamic. We partitioned the data based on department number. And we knew the department number are quite few and they were just 5 departments. So I know that there could be at the most 5 partitions, right? Now what if I had done the partition based on country and city or city and or, okay? So I do not know the number of countries in there. Probably the 300 employees in their employee records, maybe they are from 300 different countries. Let's assume they are from 100 different countries. And city, the 300 employees, if I partition on the city, probably every employee is from a different city and say 300 cities, right? So how many partitions will I have? I'll have 300 partitions here and I'll have 100 partitions here. So what's the big deal? 100 partitions or 300 partitions? It shouldn't matter really. No, but we have a small problem here. If we go back to our basics of HDFS, Hadoop file system, what does in HDFS, we need a large block size. This block size is configured. So 64 MB, 64 MB, yeah, or 128 MB block size. Why do we need a large block size in HDFS? Because it is good for sequential reads. Now if you go back to the basics again, the latency and throughput to locate that 64 MB at one place would be much faster than if you have this file scattered over different places on the hard disk. To collect that and read it, it will take a longer time. So hence we have a large block size in HDFS, right? So if I have a partition of 300 and say 300 files were created, and this was city, correct? So city was partition, 300 files were created. So just imagine every file should be at least 64 MB, because this is the ideal size we are saying. Now if they are not, 300 odd files, the name node will be storing meta information for them and this will become a hotspot. And when this becomes a hotspot, your entire system may become slow. it could well happen that you may run out of memory even for a small select, because HDFS by its very nature deals with large files and large block sizes. Okay, so if we have a fewer partitions, it will mean that the block sizes will be as close to 64 MB. Ideally, every partition should have 64 to 128 MB based on whatever you have specified in your configuration. So that is the reason why we did not partition based on city or country. Okay, even though this is a very small file. Now whenever we do some examples, it is a small file because the resources at my disposal is very less. So I am not working on a huge cluster where I can analyze 10 gigs of data or 20 gig of data straight away. I am just working on a pseudo distributed mode. This is just to demonstrate certain concepts. Okay, so that's the reason why we didn't partition on country and city. Okay, right? Okay, so now we saw what a manual partitioning is, what dynamic partitioning is. In a dynamic partition, we just specify the column name. The column name doesn't exist in the table itself. It is exists in the partition column. Okay, and what you do, you select the data from a staging table and you insert it into a dynamic partition table. Okay, so this is what you do here in this table. So you select the data from 1 and you insert into 2. Okay, and when you insert, you do the select statement in such a way that the partition column appears last in the select statement. Okay, now let's say do not know the quality of the this kind of data. We do not know we do not have enough knowledge about this data. So what do we do? Okay, so let's have a look at another table, another data file. Now, and this is a very large file. Assume this is a very large file. Obviously it's not that large, but it's a very large file. And again, all this data is in a normal table, a non-partition table, and the queries that we run on this table are becoming slower. So what's the solution? Partitioning? Yes, but what to partition on? Should I partition on this stock exchange? Okay, I'll have to give you some information about this data. This is a stock exchange, this is a script or the stock, this is the date of trading, then we have open, close, high and low and adjacent close, and this is the volume. Now how do you partition this data? It is quite difficult to partition this data because I do not know how many scripts are there. These scripts could be just 10 or these scripts could be 1000 that are being traded in the stock exchange. Okay, and I can't partition on the stock exchange because it is only one stock exchange data. So it is as good as having a normal table without any partition. Okay, so in this case or in this case where here we knew the department numbers are quite just a few handfuls, say 5. What about country and city? So in these cases there is another little handy Hive utility or Hive partitioning that comes into picture. It is called bucketing. Okay. Now we do not know how to partition a table. We can bucket the table. I am not saying you either have to partition or bucket. You can first partition a table and then bucket it as well. So you can have both the properties in there. Okay. but for simplicity's sake, we'll just do bucketing, right? Now bucketing depends on a concept called hashing, right? Suppose, let me tell you about this concept. Suppose I have a large file having employees, the name of, say, John, Jane, Oleg, then Lisa, Ram. Okay. Now I'll just come in there and I query this data. When I query this data for John or Lisa, I go through this entire structure. Okay. So I read line by line and find out how many Johns are there, how many Lisas are there, and it gives me the result. Okay. Now what if I assign a hash value to John, hash value to each and every entry in there, and I create some hash buckets. So I'll say hash values 0 to 10 will be in here, 11 to 25 will be in here, and 26 to 26 and over, okay, will be here, right? So let's assume John has got a hash value of 14, Jane has got 2, Oleg has got 3, 4 and 20, 26. Okay. So when I store this data, they will be segregated into buckets. So John will fall into this bucket, okay, Jan will fall into this bucket, Oleg will also fall into this bucket, Lisa falls into that bucket, and Ram will fall into this bucket. So now when I query for John, first and foremost I'll try and get the hash value. Say the same algorithm I'll use and say, okay, oh, John's hash value is 14, and I know 14 is in this range. So I directly go to that bucket and try and locate John. Here you see there is only one entry called John. So rather than going through each and every row like I did it before, I directly got John out because of this hashing algorithm. Okay, and I segregated them into small hash buckets. So that's the concept of hashing and hash buckets. Okay. So let's look at this example now. So now what I'll do is, first and foremost, as usual, I need to create a staging table. So let me create a staging table. Created. Now I insert the data NYSE daily into staging. Right. Okay. This is the syntax for bucketing. Exactly the same columns, no change in the column. Symbol is inside the table, and what we just do is we say clustered by symbol into 20 buckets. Now what is this number? I'll just let you know. So I am assuming symbol, the number of symbols are higher than 20. So I have more than 20 unique symbols. So all those symbols will go in one of this bucket, one symbol will go into one of these buckets. So that's the number that I am assuming. Okay. So clustered by symbol
means every symbol will have a hash value and it will go into one of the buckets. Okay. So if I have 100 symbols here, it could be possible that every bucket has got a range and say 4 symbols will be in one bucket, bucket 10 will be having 2 symbols, bucket 3 will be having. So it has been clustered by. So there is no word called bucketing here. It says clustered by symbol into 20 buckets. Okay. Right. Now the last but not the least, I have to first and foremost I have to enforce bucketing. Okay. Another environment variable to enforce bucketing. Otherwise by default bucketing is not enforced. Okay. Then I have to copy the data from the staging table. Say I'll say from NYSE daily staging, insert override table NYSE. Now I'm not specifying partition by and things like that or clustered by in this. It is just select star, means select all the columns. Everything is done automatically and behind the scenes by Hive for you. Okay. So I just say enter. Right. Now it will run a MapReduce job. It will do its own thing behind the scenes and it will bucket. Again, our query performance will increase because we are using bucketing. When you run out of memory, sometimes it is good to tune your heap size. Okay. So that is the concept of bucketing that we just while it runs, we'll do a quick recap. So the concept of bucketing, I just showed it to you how it works. Okay. And when will you use bucketing? When you do not know how to partition your data based on the columns. Okay. So here you go, it is taking each and every record and it is hashing it and putting it into the right place. It may run out of memory, I'm pretty much sure. But that demonstrates the concept of bucketing. Okay. I have put a couple of test queries here. You can run these queries and see for yourself the performance. Okay. There's another variable that you can set. If you have a bucketed table, okay, and you want to gain performance, you want to have performance gains in the query, and if those tables are used in joins, set this variable so as to use bucket map join. So joins will happen on the map side. Okay, so I put a few lines in there which will help you. Okay, so I'll be giving you the script file anyway. So that, thank God it worked. Okay, there was no out of memory errors. Okay, so let's do a select from production. Okay, NYSE daily production, because that's the table that we created, the bucketed table, NYSE daily production. And I hope it gives data faster. And another query, the same query will run from NYSE staging just to see the performance gains. So it took 18.124 seconds. Okay, and here this table is not a bucketed table, and the staging table, we run the same query. So 18.124, 18.8. So it has shaved off almost 700 milliseconds from there. So that gets us to the end of this session on partitioning tables. Okay. In the next session, we'll see what are views and index.